Hey everyone, in today's video we're going to talk about corresponding angles, alternate interior angles, alternate exterior angles, and then the type of angle relationships you get when you have parallel lines that are kind of cut by transversal like we have in these diagrams here, and how you can find out the measurements of these angles without really having to use a protractor or, for the most part, really even needing a calculator for most people. So here you have three different diagrams. These are about the only ways I figured they could a book or a question could present this to you. You're always going to have, for the most part, parallel lines. Now, normally parallel lines are marked with a little arrow of some type, like this. And if you see this arrow ever on two lines, it doesn't have to be one little arrow. Sometimes it can be like two. If for some reason they wanted to put 2 on this one and then 2 on this one, because they have the same marking, you can tell that these lines are parallel, obviously lines that never touch. And then if you ever see a line that kind of cuts across two parallel lines, or even doesn't have to be parallel, but a line that cuts across two other lines is called a transversal. Trans, the prefix trans, meaning across. And so here you're going across two different lines that happen to be parallel. And whenever a transversal cuts across two parallel lines, you have some special relationships that are formed between these angles. So you can see it splits this diagram up into 8 different angles, and usually they'll be numbered like this, 1 through 8. Every once in a while they'll give you one that goes more than 8 if they do some really wacky stuff with the lines and add some other rays in here. But for the most part, you'll usually just see 8. And there's some pretty neat relationships. Corresponding angles is where we'll start. Corresponding angles are angles that are in the same position in each one of these little pairs, right? These remind me of like a foursquare court, if you've ever played foursquare, where you've got one court here and one court here, and it's almost like this angle number 1 and angle number 5. You see how they're both kind of in the top left, right? Out of this little court right here, these 4 little angle combinations, the 1 is in the top left, and then down here, the 5 is in the top left. I saw someone else's video earlier today where they said if you took this and just kind of drug it down, like imagine you're on a computer and you could take your mouse and click this and drag it down, it would match perfectly. And so angle 1 and 5 are corresponding. What does corresponding mean? It means they have the same position, and it means their measurements are congruent, or their measurements are equal. But those aren't the only ones that are corresponding, right? The 2 and the 6, those are also corresponding because they're in the top right over here with the top right over here. And then the bottom left, the 3 and the 7 would correspond, and then the 4 and the 8 would correspond. So that is what you mean when you see a question asking you for corresponding angles. Angles that are in the same position, just in each little angle quadrant, or little, almost looks like a little foursquare court, like you were an overhead shot. Over here, if the parallel lines are going up and down, same idea, right? The number 1 in the top left kind of matches here with the 5, so the 1 and the 5 would be corresponding. And the 2 and the 6, you can see 2 and 6, these are both obtuse angles, 2 and 6. Their measurements are congruent, or the same. Here, the 3 and the 7, there's another obtuse combination, 3 and 7. And then the 4 and the 8, bottom right-hand corner, bottom right-hand corner. So corresponding is actually one of my favorite ones to do because it's not too complicated, at least I hope it's not. On my last one here, I have my parallel lines kind of going diagonal. And you've got 1 and 5, which are both in this little top left-hand area. You've got 2 and 6, top right of this little foursquare court in the top right here. 2 and 6 are corresponding. The 3 in the bottom left with the 7, and the 4 with the 8. 4 with the 8. Okay, so that's what you're going to have to do if it ever asks you for corresponding angles. Angles that are in the same location, just maybe they're up here compared to down here, right? One from up above and one from down below, or one from the left and one from the right in the same location. Here's where it gets a little bit trickier, but not too bad. Alternate interior angles. Now, interior is a word you've probably heard of before. Interior meaning inside, and specifically when they say interior, they mean inside, in between the parallel lines. So like in this example where my parallel lines are going across, right, they're horizontal, the angles in here, right, in between the parallel lines, and I'm not going to color over all my numbers there, but in between the parallel lines, in between your parallel lines here, where I've kind of shaded it in with green, those are your interior angles, 3, 4, 5, and 6. 3, 4, 5, and 6 are the interior angles. Now, what about alternate? Alternate means you have one on the right-hand side and one on the left-hand side. And they should both be acute, or they should both be obtuse, right? Like if you're looking at this, angle 3 is acute, and so is this angle right here, 3 and 6. So those are your alternate interior angles, 3 and 6. And then you also have two obtuse angles, the 4 and the 5. They're both in between the parallel lines, but one's on the right-hand side of the transversal, the other's on the left-hand side, right? Your transversal that cuts across right here. This one's on the right, it's obtuse. This one's on the left, it's obtuse. And it should always be like that, right? Whenever you do your alternate interior, and later on when we do alternate exterior, you're looking for two angles that are both acute or both obtuse whenever you match them up. In my second diagram, now my parallel lines are vertical, right? Parallel lines here going up and down. And so you're still doing the same thing. In between, you don't have to shade it in. I'm just shading it in to kind of show you. In between the parallel lines, this is your interior area, in between the parallel lines. And so your four angles in the interior section here are the 2, the 4, the 5, and the 7. Now, which ones are alternate, right? Alternate means one from one side, one from the other side. Now, over here, it was one from the right and one from the left, right? One from the left and one from the right. Here, it's going to be one from up above the transversal and one from down below. But you're still looking for the 2 that are acute and the 2 that are obtuse, right? So here's the 2. This is an obtuse angle, and the 7. See how the 2 is above the transversal and the 7 is down below? One from up above, one from down below. 2 and 7. And then over here, the 5, which is an acute angle, which is above the transversal, and the 4, right? The 5 is above, the 4 is down below. Those are the alternate interior angles on that diagram. The third diagram I have over here, now my parallel lines are diagonal. Don't let that bother you. It means the same thing, right? Your interior angles are these ones in here, the ones in between the parallel lines, in between. And you can shade it in if you want to. It's really not mandatory. So I've got 3, 4, 5, and 6, once again, that are in between. They're interior angles. And then you just pick one from the right-hand side and one from the left. Your 2 obtuse angles, angle 4 and angle 5, are obtuse. And then angle 3 and angle 6. And those, each one of these pairs will be the same. So like if 3 is 30 degrees, the 6 is 30 degrees. If this is 150, this is 150. Right? If this one is 120, this one's 120. And so these, each little pair will always have the same measurement. Okay, that's interior, in between the parallel lines. And now you can probably guess. Exterior is going to be outside of the parallel lines. And so for the last example here, your alternate exterior. Exterior is the opposite of interior. So instead of being in between the parallel lines, we're either up above or down below. So we're either up above or down below. We're out here on the outer limits, right? The exterior, the outside of it. And so you have 1 and 2 and 7 and 8. You really don't need all that silly coloring on there. But 1 and 2 and 7 and 8, those are not in between the parallel lines. They're up above or down below, up here in kind of this orange area that you don't have to draw, but I just kind of highlighted it. So in my example, alternate, remember alternate means from opposite sides of the transversal. Angle 1, that is obtuse, and then down here, angle 8 is also obtuse. They are the same measurement. If one of them was 115, the other one would be 115. And then angle 2 is on the right-hand side of the transversal, and angle 7. Those are both acute, 2 and 7, and they are both the same measurement. They are both alternate exterior angles. Okay, same thing on this one. In the middle, I won't color all over this one, but you've got the interior in between the parallel lines right here. Exterior is going to be out on the outside edges, right? So way out here, I'm not going to color everything, but all of this with all of this over here, this is all your exterior out here way off to the right and left. And so you've got the number 1 angle, which is looking like it's an acute angle up above the transversal. And then way down here, you've got the 8, the 1 and the 8. See how they're on opposite kind of diagonal from each other? And then the same thing over here, the 6 with the 3, the 6 and the 3. Notice we are not even coming close to going in between the parallel lines in that green area. We're staying way out on the outside. And then the same thing with the last one, your diagonal parallel lines. You've got the exterior part way up above or way down below. Like way up here is exterior, way down here is exterior, above and below. And it's kind of diagonal, but that's okay. You've got the angle 1, which is definitely obtuse. It's going to pair up. Alternate means you need to go, if this is on the left-hand side of the transversal, your other one needs to be down here on the right-hand side. 1 and 8, those are both obtuse. And then 2 with 7. Those are alternate exterior angles as well. So that's, I think, the hardest part is just getting the vocabulary down. The easiest part is what I think comes up next. What if they give you an angle and then they ask you to fill in all of the others? You can do it. It's really not that bad. let's just say they'll always tell you one, but all they have to do is tell you one angle. And if they can tell you one angle measurement, you can get all the rest on your own, which is kind of neat. You only need one answer to get the other 7. So let's just say, for example, they tell you that this angle is 110. I'm not sure if that's really what it is, but I'm just going to act like angle 1 was 110. You can figure out all of the others, and you really don't need a calculator for the most part. You don't need a protractor. How do you know? Well, this is an obtuse angle. Every other obtuse angle in this diagram is going to be 110, and you can use some of the rules that we just did to match them up, right? The 110 is corresponding with the 5, isn't it? It's corresponding. See how they're both in the top left hand position, right? Top left here, and the angle 5 is also 110. So that 1 and the 5 are corresponding, so that means they are congruent or equal, the same measurement. So that gives me those two. The 110 and the 4 right here, this angle, these two are alternate interior, right? Remember, this is in between the parallel lines. These are alternate interior lines, or angles, excuse me. So that's alternate interior. Alternate interior angles are always equal or congruent, so that's 110. And then the same thing, angle 1 and angle 8 are alternate exterior. They're out on the outside, and they're both the obtuse angles, so that means they are also equal. So they are congruent, and they are also 110 degrees. So you see how all 4 of these angles that are obtuse all have the same measurement, 110, 110, 110, 110, and it's always kind of a little diagonal like that. It'll always look like that. Now, we don't have the acute angles yet, but can we figure those out? I hope so, right? I don't know which class it's been, but I bet at some point you learned that angles that form a straight line, a linear pair, angles that make a straight line are supplementary. They always add up to a certain amount. They always add up to 180 degrees. And so you've got 110 right here, and then this angle, angle 2, has to make it equal 110. So if we do 180 minus 110, and you can use a calculator for that if you want, but most people don't, 70 is going to be the measurement of all of these acute angles, right? Angle 2 is 70. Why? Because it was supplementary, right? Supplementary with the angle 1. That means angle 6 is also supplementary. I'll get to 3 in a minute. Angle 6 is also supplementary. I can't speak English. Angle 6 is also 70 degrees because it's corresponding with the angle we just put in there, angle number 2. It's corresponding. This angle and the 7, angle 1 and angle 7, are alternate interior angles, so those are also matching. So angle 7 right here is alternate interior. And the 3, you could even say these that are diagonal, these are called vertical angles. You could say the 1 and the 3 are vertical angles, and so they're going to be the same measurement as well. You could say the 1 and the 3 are vertical angles. That's a word I haven't used yet. You could also say the 3 with this one up here are alternate exterior angles. That would work as well. So you see how even though we had 8 angles, there's only 2 measurements. There's only 2 measurements. It'll always be like that if they give you 8 angles like this. Now, if they start throwing some weird rays in there where you've got 9 or 10 or 11 angles, well, then things can mix up a little bit. But if there's only 8 angles like this, 4 of them are going to be acute, and they'll all be the same measurement, 70, 70, 70, 70. The other 4 will be obtuse. They'll all be the same measurement, 110, 110, 110, 110. And then the 2 numbers that you have will always add up to 180. So I hope this gives you some help on any assignments that you have. Feel free to email me and ask me any questions or leave a question in the comments. Have a good one.